Welcome to Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle. I'm here with my co-host Gary LaRude, and we have a special guest with us today, Kevin Hipas, is Product Line Manager for Antennas at Pasternak. Welcome, Kevin.
Thank you very much, Pat. Appreciate you having me.
So Pasternak has a very wide variety of product offerings, but let's focus on the antenna area. What main trends are you seeing in the 5G sub-6 gigahertz antenna market?
Great question. So yeah, we're seeing the antennas for 5G and specifically sub-6 gigahertz having a really big boom in this past year and looking forward. We're seeing a big growth in the low frequency range of it, under 1 gigahertz. So the 600 megahertz band is getting a lot of traction thanks to some of the large carriers doing a major deployment, and then a push all the way up to the extended CBRS bands. And those, the fact that those are unlicensed is really gaining a lot of traction and a lot of use out there. From a technology standpoint, we're seeing a divergence, I'd say, from the historical 4G, where you had macro cells and that was pretty much it. You put up a big booming tower and blast wherever you can. And now you're still getting that and larger antennas with the massive MIMO and the beamforming, but then really going to this small, very nanocell almost deployments out there.
So it seems that antenna selection gets pushed off to the end of the design cycle, yet obviously the antenna is a critical component and it really needs to be part of the system definition. What performance parameters should system engineers consider when selecting an antenna for a sub-6 gigahertz 5G application?
So yeah, you're absolutely right. Historically, antennas have always been selected at the tail end, which is where we come into play on getting products out right away to customers. But things to consider, obviously, frequency range being the top one. Frequencies are spreading out more and more and more, and they're being refarmed constantly. So having a product that will handle not just today's needs for your 5G deployments, but potentially future-proofing. If you can get an antenna that's covering your 600 meg to 6 gigahertz, and that way, you've got all those future requirements covered, it'd be great. Next is you want consistency across those bands, because you are trying to cover one footprint on a very wide spectrum out there, which can be difficult to do. So you want to make sure your pattern coverage, your gain, and your VSWR are consistent across that large band of operation. And lastly, I would say connector, and connector ties in with power handling and passive intermodulation performance. So you want to make sure that you're selecting something that is quality, that will last for at least the design cycles of your technology base, which is going shorter and shorter, it feels, as we go up in generations of cellular technology. But I'd rather the antenna outlast your needs versus the other way around.
So you mentioned passive intermodulation, or PIM. Is that still a concern with 5G sub-6 gigahertz? Because I heard it was less of a concern in 5G than 4G.
Difficult answer. It is and it isn't, because 5G has exponentially grown the types of products that can be used and how the antennas are being used. You're seeing one side of the equation having, fully integrated massive MIMO radio at the antenna side. So each antenna is getting very little power and not having those intermodulation points that you would have on your 4G deployments. But then you also have your small cell deployments, which are more passive deployments with low power, but it's still, you have a much more complicated, higher constellation QAM structure that any interference or noise in that is going to cause degradation. And when you want, nanosecond or microsecond latencies, as well as faster data rates, any little blip will cause a degradation in there. And then last, even on systems that historically, like a TDD type system, where it could be argued that PIM never was issue because it was always split on your time and you weren't causing that extra noise. It's a PIM rated product is still a sign of quality. It's that extra, little gold sticker that's on your product that says it's built well, it's built to last, and it's built to perform. So it's causing maybe less noise now that you're doing 2 watts instead of 20 watts or 40 or 80 watts, depending upon the product that's out there. But like I said, any little piece that gets added into the equation is going to hurt your system overall.
So this is a bit of a oversimplification, but you can kind of think of deployments in 2 categories, indoor and outdoor. As you look at those two, what are some of the considerations in selecting antennas for sub-6 gigahertz 5G, indoor versus outdoor?
You're going to have some similar considerations on there. Obviously, MIMO is a big driver for 5G. The more antennas you can squeeze in, the more diverse paths, the better data rates you will get. On an indoor consideration, you're going to need to be able to selectively control the coverage in a very small footprint and a very RF noisy footprint, I'd say, that you can make sure that you are segregating out each individual user and not over swamping each radio, because then you will get some serious reduction in your quality. From an outdoor standpoint, bigger is better. You're going to want more gain. You're going to want a consistent footprint for your beam. You're going to want as many connectors as you can toss into it. And then in that situation, isolation really kind of drives the performance of those.
So how do you see antenna technology progressing over the next few years in a general sense?
More and more complicated. Well, I see it diverging. You're going to have the very simplified pieces that are going to be the end user antennas. Your rubber ducks, your small little omnis to get that last mile connectivity. That's going to need right now we're talking 600 to 6 gig. They're expanding it down to 400 megahertz. And any I think piece of spectrum that they can grab is going to be tossed in there. So you're going to have a small little simple product that's expected to work DC to daylight almost, and be affordable to an end user. And then you're going to have I'd say the reverse side of that, which is going to be the very complicated pieces that have the multi-beam beamforming, the individualized user beam almost, to track them, give them their 64 by 64 transmit rates, and somehow be able to deploy it every 1 kilometer, so that you actually get your segmented cells right and can achieve that. It probably wouldn't be a 5G, but it's going to be a 6G consideration for connected cars, connected cities. IoT devices are going to reach the trillions. It's going to be a lot of integration, is how I see it.
So what segments of this market in terms of antennas does Pasternak serve?
So we serve more of the end user side of it. So people who are looking for either SOHO, small office, home office deployment. So looking to kind of do that, like I said, that last mile connectivity. You've got a 5G network outside, poor coverage inside, be able to put up an antenna to receive that, whether it be a small little Omni antenna or even a more directional piece. And then we're also providing a lot of the in-building products. So PIM rated, MIMO, either 600 or 700 megahertz bands all the way up to that 5.86 gig situation. So you can do a lot of your neutral host deployments, or even do some enterprise private network deployments through that, partnered obviously with radio manufacturers.
Well, thank you, Kevin, for talking with us today about 5G antennas and what Pasternak is offering in this product space.
Well, thank you very much. I appreciate it. It's a pleasure talking to you both.
And thanks everyone for watching this episode of Frequency Matters. We'll be back soon with another interesting conversation about what's taking place in the industry.